Hello everybody, and welcome to our video notes for 9.6, which is nonlinear systems. This is the very last section of our school year. Woot woot! So this is the last section in chapter 9, which obviously with only having this week to have new stuff with, this will be the last chapter that we're covering. So once you're done watching this video today, you'll know everything that you need to know for Algebra 1, at least the stuff that we're able to cover this year. So, awesome. Yeah, I don't really know where to go from there, so we're just going to go right into the notes. Today we're dealing with nonlinear systems, which kind of combines what we've talked about for most of this chapter, solving quadratic equations, and mixing it back in with chapter 5, which, if you remember back in chapter 5, we were solving systems of equations, so two equation systems, and we had 3 methods on how we do that. We could solve using graphing, so we graph the equations and find out where they intersect. That intersection would be the solution. We could also solve using substitution or elimination, which those are the 2 algebraic methods, and those are going to be the methods that I focus on today. So we'll talk through graphing real quick, because it's more so a case of what does it look like, because if you're going to graph it, if you know how to graph the 2 equations, you can always do that. But we're going to look at the 3 different possibilities for what the equation could look like. Now, I'm just going to kind of go through the definition first. A nonlinear system of equations, just like it sounds like, it's a system of equations, so it's more than one equation. 2 is the one that we'll deal with. And at least one of the equations in that system is nonlinear. Now, specifically, what we're focusing on for this section is if one or both of my equations is quadratic. So it's an x squared equation. So we have 3 different possibilities for how they can interact with each other. Now for this top row, I'll show you kind of just a sketch of what it looks like for one linear systems, and then for the bottom one, both equations nonlinear, so both of them curved. Now, the different combinations that we have in terms of possible number of solutions, this goes back to when we were working with the discriminant last week, where we were looking at, that was the backside of 9.5's notes. So that b squared minus 4ac underneath, the thing underneath my radical in quadratic formula, that told us how many solutions we have. That's basically how many intersections we can have in a solution. The same number of x-intercepts, like the number of x-intercepts we have, is the same possibility for the number of intersections we have in a system. So we could have 2 solutions, we could have 1 solution, or we could have 0 solutions, which is going to look like no real solutions. I don't know why I boxed that in, but no real solution is the same thing as 0 solutions, 0 intersections. So there's a ton of different ways that this could happen when we're going through and graphing it. Doesn't really matter where your parabola happens, but your parabola and your line are going to intersect at 2 points. That's the most common one, just like having 2 x-intercepts was the most common. Having 2 solutions is the most common. You could also have it where let's just say there's your parabola, and then let's draw something that actually intersects. Right there. Sure, we'll just draw a nice big fat point. It is possible. I just didn't feel like zooming in for whatever reason. Maybe we could do it this way. Ooh, nope. There we go. So that's exactly 1 intersection. Or you could also have it where, let's just say there's my parabola, and my line is way over here. They're never destined to meet, no intersection, so no real solutions. Now we also do have possibilities where both equations in my system are nonlinear, so they're both parabolas. And there's a bunch of different ways that you can have this for 2 solutions, 1 solution, or no solutions. So I could have them where they open in opposite directions. So maybe something like this, almost like the Under Armour logo. They intersect right there. They intersect right there. It is also possible for parabolas to be opening the same direction and still have two intersections, which I'll graph down here in red. Usually when that's the case is because one is wider or narrower than the other. You could have parabolas that look like that, facing the same direction, but they still intersect twice. One solution, a little more difficult. You could still have facing opposite directions where basically their vertex of both of them are the same. So again, they have that one intersection point right there. It is also possible, I'll switch to just different red because it's a different system. I could also have it where they both open the same direction, kind of like a W looking thing where they just intersect at that point right there, and then never again. The no solution, no real solution, zero solution, a little more distinct. You could have them face the same direction. That's very unlikely because one would have to be narrower inside the parabola, and then one, like this one, let's just opposite directions is the one we did in blue. So if we go opposite directions like that and like that, they don't intersect at all. They're facing opposite directions, so they're continue going that way. It is possible, again, like I said, unlikely. If I had a narrow parabola and then a wider one, but they don't intersect with each other, they're never going to intersect because, again, the wider one is going to continue out wider, the narrow one goes more straight up, but they're not going to intersect with each other. So those are my different possibilities for numbers of solutions. Now, I'm not going to take time right now to go back through and solve by graphing. Again, it's just graphing each part of my system and then figuring out the point that they intersect. If you're going to be doing this method, most likely it's going to be that you're using a technology tool to do that. So something like Desmos or a graphing calculator if you have a graphing calculator, which most of you don't, but again, most of you won't have to deal with these very often. When you get to those levels where you have application to these types of problems, you'll have a technology tool method for how to solve it. Okay, so on the homework or anything, I think I adjusted all the instructions, but if there's anywhere it says solve by graphing, you could, again, just hop on desmos.com/calculator and use Desmos to do that, or you could always choose one of these other methods to solve your equation. You're solving it at home by yourself. I'm not going to force you into a specific method. If the instructions say solve by substitution, if you really want to do elimination or you really want to do substitution on a solve by graphing problem, I'm not going to stop you. As long as you're doing the work, that's all I care about. All right, so jumping into box 2, solve by substitution. Now, if you forgot from back in chapter 5, solve by substitution, we're going to take something that I know is equal in one of my equations and replace that variable in my other equation. So in this case, I do have two options on how we kind of consider this or how we handle it, but the obvious one to me is that we know in my bottom equation, I don't know why it changed colors there, why it split it up there. I know that y is equal to 4 in my bottom equation, so all I'm going to do is replace y in my top equation with 4. So I'm just going to make this swap right here. I'm substituting a -4 in there for y in my top equation because I know y is equal to -4 in my bottom equation. It's just substituting those two things. I'm replacing y with -4. When I do that, I end up with a single equation and a single variable. So now I have an equation, it's just a single variable, x, and it's just one equation. -4 equals x squared plus 4, x. Once I have this, now it becomes a problem like earlier this chapter. So However you are most comfortable solving it, you can go ahead and use that method. I am one who prefers to solve by graphing first, if I can use that method, or square root method if I can. If that's not an option for us, then we would have to use quadratic formula like we did back in 9.5. Okay. So here, my first step in any equation solving is to get everything on one side, get it equal to 0. So 0 equals x squared plus 4x plus 4. So I'm trying to factor that equation. Well, I guess I'm trying to solve that equation now. Now, if I was trying to factor, if it is possible to factor this out, this is an old school 2 parentheses factoring problem, because my lead coefficient is just 1, right, just x squared, so I don't have to worry about xbox factoring at all. So now I'm looking for what two things multiply together to give me 4, but add up to 4. Because again, I always want to multiply to get this last term, add up to this middle term. So 2 times 2 is 4, 2 plus 2 is 4. So x plus 2 times x plus 2 is how I would factor that particular polynomial. So from here, I'll switch my colors for the next piece of the puzzle, because now to get my x value to solve for x, I'm just going to set my parentheses equal to 0. Now we can see the parentheses are the same, so we're only going to get a single x value, which is fine because it makes less work for us. Minus 2, and we get that x is negative 2. Which I would get the same thing twice. We don't have to repeat a solution because it's a repeated solution. Now I have my x value. Usually I would go back to one of my two equations and plug that x value into that equation so I knew what y was. But in this case, we're actually in a little bit of a unique situation because I started off already knowing what y was. I knew that y was negative 4, so I don't have to solve for that again. If I plugged in negative 2 in that top equation, I'd better get negative 4 back out, which if you check it, it does. It does give you negative 4. So to write out your solution, we'll use, no, I don't like black. Let's do, no, we were just in red. Let's do pink, because what's life without whimsy? So now we figured out that x was negative 2, y was negative 4, and that's what was provided to me. So negative 2 comma negative 4 is my solution. Your answers for systems should always be ordered pairs. In this case, it was just a single point. So this would be a case where it would look something like the top middle one, because we have one equation that's quadratic, one equation that's linear. So that's what it would look like. In this case, actually a horizontal line at negative 4. Okay, so that's substitution. Now I do want to do a more complicated one with you with substitution. That is 9 times out of 10 the method that you're going to be doing for solving these. Just like with solving our linear systems of equations, substitution is by far the most common, the easiest is what I would say. So we'll go ahead and do that again. So starting off, in this case, it doesn't really matter which way you consider it. Y, you know, is, oops, there we go, negative 2x plus 3. Let's space that out a little bit there. So I'm going to just do that substitution there for y. So my updated equation, negative 2x plus 3 equals x squared plus x minus 1. So now I've got a single variable, single equation. I'm going to rearrange my equation a little bit, get everything over on one side, get it equal to 0. Here, I'm going to go ahead and leave my x squared on the right side, since it's already positive. So I'm going to go ahead and add 2x on both sides. Subtract 3. 0 equals x squared plus 3x minus 4. So now I've got that equation to try and solve. Let's actually do blue here. So now if this is factorable, I'm going to go ahead and do that first. Otherwise, again, you could use quadratic formula. Your A would be 1, your B would be 3, your C would be -4. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. If you want to use quadratic formula. Personally, I only use that when I have to. So I'm going to try factoring this bad boy first. So again, when I'm factoring just regular 2 parenthesis factoring, because this is just x squared to start with, I'm looking for numbers that multiply to get -4, but add up to a +3. Now since they multiply to get negative, one's going to be positive, one's going to be negative. And in this case, I want the bigger number to be positive because I wanted to add up to +3. So in this, if I have +4 and -1, -1 times 4 is -4, -1 plus 4 is +3. So there we go, x plus 4 times x minus 1. From here, I'm going to set each of those those parentheses equal to 0. There we go. X plus 4 equals 0. X minus 1 equals 0. So I subtract 4 on both sides. I get -4. I add 1 on both sides. And I get +1. Now in this case, we do end up with 2 unique x values, which means we have 2 solutions. Now when we solve, I still need to get ordered pairs, so I need to figure out what are the y values that go with each of these x values. So just like I described before, I'm going to take that x value and plug it back into one of my 2 equations in my original system to find y. Now, as long as we solved correctly, it does not matter which of the 2 equations you plug it into, so it's your choice. If I have a linear and a nonlinear, I would always choose the linear one, depending on what the equation looks like, because usually it'll be easier to solve, easier to deal with, but that's also up to you. In this case, that top equation doesn't, even though there's a squared in it, they're not overly complicated. There's no other multiplications happening, so maybe you want to do that one. It's up to you. It does not matter to me. As long as you take that value and plug it into one of my 2 equations, that's all we have to deal with for finding the y value. So I'll just try and, I've got plenty of space down here. So if I plug in -4, I'm going to use the bottom equation, which is y equals -2 times x plus 3. Y equals -2x plus 3. -2 times -4 is a +8, plus 3 is 11. So -4, 11 is one of my 2 solutions for this system. Let's switch to red just for a different color. I'm going to do the same thing except, -2 times 1 plus 3. Y equals -2 plus 3. So y equals +1. So 1, 1 is my other equation. My other solution. Why did you do that? That was weird. Let's try that again. That's better-ish. Okay, I guess you locked it in a square. Cool, good for you. 1, 1. That's the most likely scenario you're going to deal with. You're going to solve an equation that's factorable. You'll get 2 solutions for your x value, so you'll plug them back into one of your 2 equations and get two y values. Okay? So that's solved by substitution. Box 4 goes to solving by elimination. So you remember from elimination in chapter 5, elimination means that I'm trying to get my 2 equations manipulated so that when I add them together, if I add the top plus the bottom, one of my two variables cancels out. One of them are eliminated. Now in this, that's still going to be the basic method that we're going to be doing. It's just that in this case, it's very, very difficult to eliminate your x values. Because we're nonlinear, at least one of your equations is going to have both an x squared and an x term. And being able to manipulate your equations in a way that both of them cancel out, both your x squared and your x term, is unlikely that it's going to be possible. And if it is possible, it's not going to be easy. The easier method here is to get your y values to cancel out, to eliminate. And usually that actually is pretty straightforward because my equation here for both of these is just y already by itself. So all I really have to do is try and manipulate this a little bit so that when I add them together, they go away. Which, remember from chapter 5, that means my coefficient is going to be the same, but one's going to be positive and one's going to be negative. So to start with, I'm going to take one of my two equations, doesn't matter which one, and I'm just going to multiply by a negative 1. I'm just going to switch the signs. In this case, I'm doing it with the bottom equation because it's a simpler equation, fewer number of terms. So if I do that, my new equations, top one doesn't change, y equals x squared minus 3x minus 2, and my bottom equation now becomes negative y equals positive 3x plus 8. Now you can see I kind of adjusted already, knowing what this next step is, and I kept my like terms stacked over top of each other. Because now that we have that, all we do is add up going down. My y and my negative y cancel out, they make just 0. X squared and nothing else collected together is just x squared. I actually kind of have a double elimination, but really just of my x to the first term. 3x and negative 3x add up to 0x, and then negative 2 and 6, or negative 2 and 8 is a positive 6. So that red equation is my single variable, single equation that I'm going to be asked to solve. So if I continue trying to solve that equation from there, this is not factorable. There's no x term in the middle, and that's not just difference of two squares. So my two choices are either square root method, which is the one that I'll show you, or quadratic formula, which again, not nice. For my quadratic formula, if I was going to do that method, my a value would be positive 1, my b value would be 0, since I don't have an x term, and then my c value would be positive 6. And again, that's your a, b, and your c. Your formula for quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. But that's not the nicest. The nicest way is, let's switch to green here, square root method. So in this case, I'm getting my squared term by itself. So negative 6 equals x squared. Once you have that squared term by itself, you're simply going to take the square root of both sides and then simplify. So usually you'd be able to get a number here, but if we use our kind of holistic thinking, we do some analysis here, we're trying to take the square root of a negative number, which we know what should happen then if we try to take the square root of a negative number. No real solutions. Yay! Why did you not make a box? Boo. Now it made a box. Yay! And we come full circle. If you take a look at the whole thing, box 2, we solved using substitution. Y was negative 4, so we plugged it back into y in the other equation, solved. Hey, look, we got one solution. Box 3, we solved using substitution again. We just replaced negative 2x plus 3 for y in my top equation, solved using factoring, plugged each of those 2x values back in for the y value, 2 solutions. Box 4, we solved using elimination. We got my y values to be the same coefficient, one positive, one negative, added up going down. We then used square root method to try and solve that, but we got a negative underneath my radical, which means no real solution. Okay. That is it for both this lesson, I guess this lesson, this chapter, and this school year. That is the last new thing that you guys are learning this year. If you have any questions, if you were confused, obviously it's a video, and if you're not already doing this, feel free to go back, pause, rewind, rewatch, re-listen to me explain stuff. It's on YouTube, so if you want to adjust the playback speed and slow me down so you can understand the words that are coming out of my mouth, go ahead and do that. The homework for tonight, which this is Tuesday, is when this video is supposed to be the lesson for. If you're watching it on Tuesday, awesome, you're on track. If you're watching it before, awesome, you're ahead of the schedule. If you're watching it after this, that's fine, just get your stuff turned in. Homework for this section is page 530, 4 through 30 evens. If you are struggling, if you've watched this video over and over again and I'm still just talking gibberish and you're just needing some more clarification, reach out. I am here for you. Even if this is the first time I'm hearing from you in quarantine stuff, that is fine. I'd rather have you reach out to me now and get some stuff done because there's still time, and still get your credit for this year and not have to retake the semester over again in the spring of your sophomore year. Because in case you guys didn't read Mr. Henge's letter that he had sent out last week on Tuesday, you guys need to get at least 70% of your assignments in for fourth quarter, which is everything we've done since we've been e-learning, remote learning, whatever you want to call it, quarantine, stay-at-home learning stuff. 70% of those assignments need to get turned in order for you to get your credit. As long as you get 70% of those grades in, then you will keep, at minimum, the lowest score you could get is whatever you guys got for third quarter. If you get everything turned in and you do way better than you did in third quarter, your grade will go up. If you don't get at least 70% of those assignments in, regardless, even if you had an A in quarter 3, if you don't get at least 70% of those assignments done in fourth quarter, then you're going to get an incomplete, and you have to take this class over again. Even if they change the graduation requirements for how many credits you need by the time you guys graduate, Algebra 1 is still a foundational class that is still a requirement. You will not be able to go on to fulfill the rest of your math credits until you pass Algebra 1. So please, 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 don't just think that you could ignore it and it's going to go away. It's going to mess your schedule up, and it's not going to be a fun time. So please, get your stuff turned in, reach out to me, make a plan. Those of you who have been doing that, I appreciate that. It is so beneficial to you and me. It makes my life easier. It makes your life easier to stay on top of things, and I'm glad for those of you who've been able to do that. For those who have been behind and who have not sent me anything, get your butt moving. You guys have until May 20th. May 20th is the deadline for when incompletes are due from me. So if you have your stuff, 70% of the assignments turned in by May 20th, then you're good. You'll keep whatever your fourth quarter, your third quarter score is. Or if you do more than that, your grade could go up. Just get your work in, please. Okay? I'm here if you guys need any help. If you have any questions about academics or specific to our class here, just let me know.